Hello and welcome to Advances in HD Technology. My name is Michael Grotticelli, Editor-in-Chief of HDCameraGuide.com. With me today is Larry Thorpe, Chief Executive of Marketing for Canon Broadcast. And we're here today to introduce the new DIGISUPER27 Studio Lens, perhaps Canon's most sophisticated lens ever. You know, it's been 10 years since Canon introduced their last really high-end studio lens, and now we have the 27, which kind of surpasses that. You know, why did it take so long for this lens to come to market?
Well, we have a very extensive R&D group, and they never stop. Optical sciences, materials, they're always advancing, slowly, steadily. And this is new glass materials, this is new exotic materials for optical coatings. Computers get faster and faster. Software design packages are advancing. And over a decade, you end up with an arsenal of tools that allow you to design a very serious new lens like what we have here with the XJ27.
Very nice. How much has customer feedback figured into the design of the lens?
Oh, a great deal. The predecessor XJ25, which we sold to all the major networks in the United States, South America, all over Europe, Asia, to some major customers who gave us a lot of feedback. They'd always find something. And of course, our folks would deal with that over time. And you accumulate a lot of wisdoms from major customers that do get cranked into the next generation design. And they did certainly much in this new lens.
So Canon does listen, is what you're saying?
I think we listen very closely.
Very nice, very nice. The thing that's very interesting or exciting about this lens is it's got a really wide focal length. We're talking about 6.5 millimeter to 180 millimeter, am I right?
That's correct.
Why such a wide range for a studio lens?
Well, start with the 6.5 millimeters. That's your wide angle, and all customers will always appeal for the widest angle you can possibly give them with very high quality. And that's because studios come in all sizes, and you don't often have an opportunity to position the lens far away from the object, and you still want to get the whole set in, so you want that ability for wide angle. The longer zoom length, like the 27 times zoom, might be a little questionable, but there are those shows where you need telephoto. For example, a home shopping type show where you want to zoom in on a tiny little ring and fill the screen with that ring. That's where your longer zoom comes in. Not required all the time, but certain shows. So what we try to do is provide the long zoom and the wide angle in one lens.
Because you never know what you're shooting, right?
Cover all applications.
Very nice, very nice. The lens, interestingly enough, has a thing called a zoom-through feature or lens adapter, which is really an industry first for studio lenses like this.
Yes, it's a wide-angle adapter of 0.9, so you put that on the front of the lens, and that 6.5 millimeters can become 5.85 millimeters, so you get even wider. And you put this adapter on the front, it's a 0.9 as we say, and it will make the 6.5 millimeter a 5.85 and buy you a little wider again. And a beautiful example of that was very recently, Saturday Night Live with NBC. They have a big set, they wanted to get the wide angle, but they wanted to get the main part of the set inside the 4:3 that will be cropped out of the 16:9 image. And so that they get the benefit. And that's where the wide angle adapter was a beautiful solution for that.
It also makes Saturday Night Live look so great because when you go there on set, the set looks so small and kind of cluttered, but on screen, on camera, it looks beautiful.
It looks terrific.
So it's because of the lens.
Exactly.
There you go. The lens has a lot of interesting proprietary technology, I noticed, in this thing. And one of the things is it deals with what's called light transmissions, or the problems with light transmissions. We get artifacts, that kind of stuff. And there's some kind of technology in here that actually protects against that. You know, how does the lens do that? How does it avoid those kind of things?
Well, it takes a lot of design. I mentioned all the materials that we're always developing, the optical coatings that we're always developing. And it is the assembly of all of that that gives our engineers the tools to combat these sort of problems. I mean, in a lens, what you really were trying to do is get the maximum light transmission through the lens. That's your sensitivity. 100% light comes in, you'd love 100% to come out, but it doesn't. Every glass element, if it's uncoated, incurs 3 losses of light transmission. One, there's an absorption in the glass itself, small, but there. When the light impinges on the front surface of that element, there's a reflection, 4 to 8% if it's uncoated, depending on the index of refraction. Goes through the element and then hits the next surface, another reflection. So you've suddenly lost maybe 8 to 16% in one element. In a multi-element lens, that accumulates and your transmission efficiency can drop very rapidly. So coatings were developed back in the World War II era to combat that. You deposit certain metallic materials, very, very thin, and that creates a second reflection, which cancels the first reflection. It's a brilliant design.
Okay.
And, but you have to put this on with tremendous precision. You're dealing down in fractions of nanometers here. And that's, of course, the science of optical coatings. But anyway, the end result is twofold. First, they raise the transmission efficiency, light through, so we're raising the light signal, if you will, through the lens.
Sure.
But because you're also eliminating these reflections, that gets rid of a lot of light scatter that can bounce around the inside of the lens and contaminate black reproduction. And I call that the optical noise, flare, veiling glares, etc. So you're pushing that down, you're pushing the light transmission up, so your optical signal to noise ratio, if you will, is being elevated.
Sure.
Which is contrast ratio.
That makes sense.
And contrast ratio is all about the brilliance and clarity that a lens can deliver. Tremendously important.
The lens actually, I believe, comes in two different configurations. One is down to the standard 27. The other is the 27 AF, which includes autofocusing technology developed by Canon.
Yes.
Explain generally how it works.
Yes, we offer one lens with the autofocus built in. It's part of the optical system, and then a second lens without it, so whichever the customer wants. The technology was born in our digital still image cameras, the SLR camera series. Sure. Where we developed a very novel detection system that has a long mouthful to describe, and I'll leave that for the illustration. But it's a dual sensor system, two little secondary optical systems, two sensors, and we measure distance. When we go out of focus, these optical systems, the detection is moving, and we measure distance. Okay. Now, what the beauty of that is we know which way we should move the optical elements. We know whether we're out of focus back or front, and we know we've got to go to a certain distance, so we're able to immediately and very rapidly converge on a focus, autofocus. And that's very important, that it be fast, reliable, no overshoot. And that's the strength of this system. Then for the digital still image cameras, where they're dealing with burst frame rates and perhaps a subject moving with some rapidity, like a racehorse, motorbike, we want to be able to track. And this system has a great strength in tracking moving objects and maintaining that precision focus. Okay. Now, when we came to put it in a high definition lens, where now our burst shooting is 60 frames per second of HD, that strength really came to the forefront, and we refined it even further. We've very high speed digital system in here, very high speed detection. We don't have to wait to accumulate frames of video. We look spatially at the image, and we're correcting all through a single frame. So very, very rapid. Big, big advantage.
One thing I would say that what I find about the autofocus is great also, it would be great in robotic situations, places where there aren't cameramen, quite honestly. Talk a little bit about that, how that could help us.
Yes, indeed.
That and virtual sets as well.
Exactly. And there's a move today as the broadcasters transition to high definition news. There's many who are seeking to try and automate the news control room for the studios and try and bring it down to ideally one person. And that poor one person has to look after the video and the cameras, the audio, the graphics, and many other things. And if the cameras are on robotics, prior you would have to bring the focus as a remote control to this single person. But now by having autofocus, we remove that control so that person doesn't have to worry about the camera focusing, and that's very important. He's got enough to worry about.
Right.